Cool, we're recording. Hello, everybody. Welcome to Rocket League again, week 3. This is going to be the last lesson on how to build and design your rockets. Today, we'll be going over the actual building process physically. Let me see chat. I'm going to give us an idea of deadlines. To be on to be clear about it. We're not going to, okay, just really quick to answer that question. We're not going to necessarily give you deadlines on, oh, your team has to meet this, this, this. What I'll do is I'll give you, say, in 2 weeks, you're going to have your design. And then after that, you're going to have to build your rocket, or you know what I mean? So I'll give you guys deadlines on when to accomplish certain things. And that's how you're going to, work that out with your team. Yep. Cool. Alrighty, back to what I was saying. Week 3, this is going to be all about actually building your rocket physically. And we'll also go over SolidWorks. Actually, no, let me change the order. I'm going to do SolidWorks first. Sorry about the sudden change. But it makes more sense to me to explain SolidWorks first before I go on to building, since this is still design. But anyways, first SolidWorks, then I'm going to go on to the slides to show you how you're going to turn your rocket from computer to real life. So let's start here on SolidWorks. There's a few parts that are going to be made out of wood. If you guys remember from last week, those parts are your fins, bulkheads, and centering rings. So you're going to have to actually model these out in SolidWorks so that they can be laser cut in the TI lab. Another thing is that we're probably not going to have you guys make your own nose cones. But if you do end up doing that, I can also show you how to make nose cones really, really quick. So let's talk about the important parts, which is fins and bulkheads. So the way that you always start anything in SolidWorks is you go here onto part. And then it's going to load for a second. And then it'll go over to a new window for you to actually, draw up a part. So you can see my screen. Now we can draw, I'm sorry if there's background noise, my roommates are here. But anyways, we're going to go ahead and we need to start drawing things. So the way that we do that is we hit sketch, hit that. Then you hit sketch again up here. And you notice that there's these 3 planes. Wherever you put your part, it doesn't really matter. You can put front, top, or right. Whatever you choose, just choose one and there. It'll center it like this. You'll see this axis here. So now on this plane, we're going to start drawing out our fin. So what does that look like? Well, I'm going to start off with kind of like a rough draft, if you will, and then I'll go ahead and put down the dimensions. I have Open Rocket open with kind of like a mock rocket, and I'll just be pulling random dimensions from that. So what you're going to do to draw your rough draft, hit the line tool. This will let you draw lines. And so what I like to do is I like to go to the center here, and you can see how the circle goes up in the middle. And you click. So this is going to put a line at the center of the axis. And you can see that I have a line coming out. So what I'm going to do is I'm going to kind of slowly push it to the horizontal. You can see how it snaps. And you see at the kind of like the bottom of the pencil, there's that line. That means that that line is perfectly horizontal. So if I go out, it'll snap horizontal. So you're going to place this here. The way that I'm building the fin, if you remember how the fins looked, they have, the top part of the fin here, kind of like this, but then it doesn't just go flat like this. There's the fin tab that goes down into the rocket. So actually, let me help you guys visualize that. So we have a line here. Let me go ahead and switch screens over to the Open Rocket. Okay, here. So this is the rocket that I made just completely randomly. So you can see the fins here if you see the darker outline. So we have the fins, but then there's the fin tab that goes into the rocket. So essentially the way that I build my fins in Open Rocket is I start with this bottom line at the fin tab, go up, side, up, and basically draw around. So what that looks like in SolidWorks really quick is I start with the bottom of my fin tab, go to line, and now I'm going to hit here, and now I'm going to go up on the fin tab. I'm going to go to the right. I'm going to go up to kind of form the side of the fin here. I'm going to go out for the tip cord. I'm going to go down, and you can see the amount that I want to go down. You see this dotted line, how it hits this point here? That means that it's in line with that point. So you're going to have this perfectly straight part here. So you can hit here, come in so that the dotted line appears above this point, go straight down, and you see how it fills in because now you have this enclosed part. Does that make sense? I kind of went a little bit fast, but that's basically your rough draft of your fin. So if there's no, oh, check. Okay, cool. Yes, that's good. So now what you need to do is you need to actually put down the correct dimensions. You have this nice arbitrary fin, but all of these points are arbitrary, so you can move them around and really change the shape of your entire fin. So what you want to do is you want to define basically where they are in space. You can see that these lines are blue. This means that it's undefined. So something about it is not measured, if you will. So you can see how with this dot, the tip chord is not defined. The height here is not defined, and even the sweep length is not defined. There's a lot of points that aren't defined. Same thing for here. If you go to this point here, this dimension here isn't defined, and even the height here is not defined. So the way that you define these things, probably shouldn't have done that. That's fine. The way that you define this stuff is you see this up here, smart dimension. What this does is it allows you to basically determine the dimensions of different parts of your fin here. So where do you get the dimensions? Well, if we go back to OpenRocket, we can actually find out what the dimensions are. So back to OpenRocket, you can see my application. If we hit our fins, you can see all these little statistics here. And you can see here, root chord, tip chord, height, sweep length, and angle. All that stuff is going to help you out to determine what your fin's actually going to look like. And then fin tabs here, you can see tab length, tab height, and tab position. So let me start with the fin tabs because it's really easy. Tab length, 2.321. Okay, so let's remember 2.321. I'm going to smart dimension, hit this, and then do 2.321. There. So now this is, oh, I hope that you guys saw that. 2.321 in length. And then I'm going to be switching a lot back and forth. Yeah, unfortunately, I can't like share two separate screens at once. But anyways, back to tab height, 0.945 inches. Cool. So let's go back over to SolidWorks. 0.945 was the number. So I hit this, kind of drag out, 0.945 inches. Oh, and one thing I forgot to mention, guys. Before you do any work, I did this kind of wrong. Look on the bottom right. Make sure it is in IPS because you want all these dimensions to be in inches. Here's why. The laser cutter at the TI lab measures in inches, but does not convert. So it's happened before where a team has put centimeter, gram, seconds, measured everything in centimeters, and put that into the laser cutter, but it doesn't convert. So 6 centimeters became 6 inches. And they had these like gargantuan fins and parts. It was very funny, but that's wrong. That's very, very wrong. Luckily, they were able to use the spare material inside of the fins to go ahead and cut out what they needed. But do not fall in the same fate. Please, IPS, first thing to check before you do this part. Anyways, back to this. So we have our fin length and our fin height. Or the fin tab, sorry, fin tab length, fin tab height defined. Cool. So now let's go back and we need to do the rest of the fin. So if we go back to OpenRocket. Now, here's where a little bit of some weird math comes in, because what I'm going to do next is I'm going to determine the front end and back end lengths. But the thing is, what do you have? You have a root chord. And you also have this tab length, but it's like, how do you know how far this and this need to be? Well, it's simple. With the tab position, you can actually kind of math your way out. You see, if we move the tab position here, it's going to move it back and forth. Ooh, I kind of messed up the dimensions. Give me a second, guys. I shouldn't have done that. But I'm just trying to prove the point that the tab position is going to help you kind of determine where it's got to be. Calculate automatically, that's a lot better. So tab position 0.361. And so that will be in relation to the back end here. So this back end is 0.361 inches. Okay, we put the other centering ring back. Oh, that's wrong. Okay, this centering ring needs to be put back in place. Okay, so 0.361. So I'm going to go back onto SolidWorks. And smart dimension still up. Hit this here, 0.361. There. So that's this length. Then what we do is we take this 2.32 plus 0.36. I should have calculated this ahead of time. Let me just pull up my computer calculator real quick. So this is going to be a little difficult for me. 0.361 plus 2.32 close enough. And now if we take, this is going to be 2.681. And if you subtract 4 from that, you get 1.311, 1.319. So that will be the front length of our fin. So I need to remember that. 1.391. Cool. And the way that you can verify all this stuff is if you added all these values up, it should get to 4. I hope it gets to 4. If not, then I did something very wrong. Let me just check my work real quick. So 1.39 plus 2.32 plus 0.36 is equal to 4.07. It's not quite, but it's close enough. When you guys do it, of course, be more careful than I am. I'm just trying to give you a rough sort of idea of how to do it. But that's your basic process on how you determine this length here and this length here. So what next? Well, let's get the height. So if we go back to Open Rocket, and I'm sorry for jumping back and forth. I just really want to help you guys visualize what this looks like. Have you guys been able to see my trapezoidal fin set configuration this whole time? I'm not sure. And I just realized that maybe you haven't seen anything that I'm talking about when it comes to the fins. Yes, okay, cool. Here I am thinking, oh no, maybe they didn't see it at all. Okay, anyways, height, 2.7 inches. Simple enough. We can go back to SolidWorks. Smart dimension. The way that you're going to do fin height, do not press this because you're going to get this. Oh, well, actually, no, that's fine. Make sure it's not this horizontal length. It's going to be this vertical length. You see how it kind of can be slanted or straight? Make sure it's straight. And it was almost correct. 2.7. Okay. Another way to do it is if you're to hit this point and then this point up here, you can do that. But that's not necessary. We got on this side. So what next? We need to get the sweep length here. So back to Open Rocket real quick. Sweep length, 1 inch. So the sweep length is how far the bottom point is to the top point here. So if we go back to SolidWorks, we can go ahead and use Smart Dimension. We hit this point, and we make sure that it's horizontal like that. You click, you press 1. Okay. So some things are not defined. Oh, I think that might not be defined. Let me see something. And I was able to make this well-defined really easily back when I was doing it on my own. And now, of course, here I am. Let's see here. I have the height. I don't think I've ever defined the tip chord, have I? That is completely my bad. No, I did not. So we take this and define it to 2 inches. Okay. So now, and you see how some of the lines are now becoming black? This means that those are like perfectly defined. Like everything is good for those. And one little trick I'm going to teach you guys, you see how these things are still blue? That means that there's something that isn't defined. And I don't know what it is. So a good way to do it, take off Smart Dimension and hit something and kind of move it. You see how this moves? So I'm trying to move it back and forth. It's not because this is defined, but I can move it up and down. So what isn't defined is basically this height here. Even though that line is black, that height hasn't been formally defined. So I can go Smart Dimension, click here, 0.95. There, the whole thing is defined, as you can see. So now that is the basic form of my fin. This all makes sense, right? The way that I've kind of broke it apart, did one measurement at a time, and make sure that all the lines are black so that this part is fully defined. Everything is dimensioned. If I try to move any point, it is not able to move because it's anchored down to some physical point in space. And the trick that I showed you earlier of like grabbing something and moving it around can help you determine what part isn't defined. So the next step, what you're going to do, you can do this. I just do it for fun. Extrude boss and base. If you have SketchUp here, you can go to Features, Extruded Boss or Base. This can help you make it 3D. make it 1/8 inch, because that's how thick our ply is. Hit check mark. It's not totally necessary, but it makes your fin 3D. If you hold down middle mouse button for SolidWorks, you can rotate. And if you look on the bottom left on the axis, you can click and it'll align it. So you can do it to Y, to X, and to Z. So this is your fin. This is what it looks like in SolidWorks. So now what you can do is, of course, you save it. I would suggest onto desktop. I'm gonna call it fin demo. Save. That's not all. Not only do you want to save it as a SolidWorks part, just to have the editable SolidWorks thing, you're going to have to save it as what's called a DXF file. And the reason why is because the laser cutter at UCF doesn't take SolidWorks parts. It basically takes like a vector that tells the laser cutter where to go. So the way that you set up the DXF file is you go to File, Save As, and you guys can see my Save As window, right? You need to see that. Yeah, I hope you guys can see this, but in essence, if you look here, there's a bunch of options. You're gonna see DXF right there. Yes, good. So you're gonna hit DXF, and then you're gonna hit save, but you're not done. So you see how this window pops up? How DXF works is it basically takes a snapshot of what you're looking at and makes like a line version of that. So when you're making your DXF file, make sure that you hit Z on this axis. If you capture the DXF like this, it's going to be wrong. Hit this, Z, that's correct. Super important that you do that. You hit check. And it's gonna take a second. And now you can see what the DXF file looks like, these lines here. And basically this is what the laser cutter takes, and it just cuts in this direction here. You know what I mean? And then what you do is you save. And then, oh, I guess it didn't let me name it. That's fine. Yeah, I think I'll just keep the same name as before. But let me just demonstrate to you what it looks like when you do it wrong, just so you know. Fin demo. Let's do wrong. There. Save. Okay, so let's do it like this. Okay, so it's offside. Slop. Check mark. It's gonna take a second. You see that? So the laser cutter is not going to print out this like 3 thing. It's gonna cut this. It's gonna cut these lines. So you're basically gonna have like this piece here, you know, that piece, that bad, very bad. If your DXF file looks like this, you have done it wrong, and you need to make sure they hit Z before you actually commit to the DXF. So does the making the DXF file make sense? Because you will need to do that in order to submit your files to the TI lab for cutting. If that makes sense, then that's literally it for fin formation. But that's not all. Next up, we're going to go to File, New, because now we're going to make bulkheads. If you guys remember in OpenRocket, stop my share and go back to OpenRocket. The bulkheads are the circular parts. Let's take this one, for example. It's on the bottom of my payload bay. This little bulkhead here. All bulkheads are very, very easy to make. All a bulkhead is, it's a circle. And the dimensions is 3 inches in diameter. That's it. I guess the thickness should be 1/8. But yeah, that's nitty gritty. Either way, the diameter is 3 inches. So all you do, go to SolidWorks, go to this. Then you're going to go to Sketch, Sketch, front plane, it doesn't matter. Circle. On the middle, click once. And you can drag out to make your circle. Click anywhere. Smart dimension. Click, click. 3 inches. Oh wait, sorry, this is the diameter. So one thing to keep in mind is that this dimension, SolidWorks loves to make the diameter here. The way that you would know is you see how it measures from this point up here to this point down here. That's like the total like length of the circle, or in other words, the diameter. So if you have a 3-inch radius, you need a 6-inch diameter. So just pay attention to that. But anyways, once this is done, if you feel like it, you can go to Features, Extrude, 1/8 inch, check mark. That's it. That's a bulkhead. Very, very simple, guys. And then you go Z, and I'm just gonna save as bulkhead demo as a SolidWorks file. Then I'll go ahead and save as a DXF, just like before, so that it can be cut in the wood. DXF, save. Make sure that it is oriented like this on the Z plane. Check mark. Yep. See, it's a nice circle. Save. Cool. That's it. That's a bulkhead. Very, very easy. Now what we're going to do is we're going to make setting rings. Okay. And if you remember these setting rings, let's go ahead and go back to OpenRocket. These setting rings were down here by the fence, you know, around the motor tube. Very important. So the way that the setting rings are going to work is you're basically going to have like a big circle, like a bulkhead, but then a cut in the middle. And if you look on the setting rings, it'll tell you the outer diameter is 3 inches. So you're going to have this 3-inch bulkhead, but then you're going to have like another circle in the middle that's on 1.21 inches in diameter, and you're going to cut that out of the bulkhead. So the way that you're going to do that is we're going to go here, file new part, start a sketch. We're going to hit the front plane, make a circle. I'm going to go ahead and dimension it to 6 inches in diameter. Okay, now what I'm going to do is I'm going to make another circle, hit the middle, and kind of push out. So you can see how there's this other middle circle here. Smart dimension, hit here. If it's 1.21 inches radius, it's going to be 2.42. Yeah, 2.42 diameter. So now what you can do, and this is where the extrusion helps. If you go to extruded boss and base, you should be able to go ahead and extrude. And you see how it's actually omitting the middle part here? When you click check mark, boom. That's a setting ring. And that's how you make that hole in the middle. Oh, wait, really? Uh-oh, that's not good. My bad, guys. That is interesting. I have an idea. Share screen. Do you see it now? I hope you do. Let me know if you guys see it or not. Yes, cool. Okay, let me redo that. Okay, let me just make a new one, whatever. New part. I'll just go over it again. So how you do it? Sketch, front plane, circle, make a bulkhead again with a 6-inch. Then you make another circle, and what you're going to do here is you're going to click on the middle. You're going to kind of go out from the middle of the circle here and dimension it to, in this case, 2.42 inches. And the way that we saw that, just to make sure that you guys know, if you go on setting ring, there's the outer diameter, same as the bulkhead, but then the inner diameter is this. So in essence, when you're, ooh, someone's mic is live. If your mic is on, please mute. Thank you. Anyways, that inner diameter is basically going to be the diameter of this middle circle here. So that's how big that hole is that you're going to cut out. So we're done dimensioning. Features, extruded boss and base, and you can see that it omits the circle in the middle. So if you go 1/8 inch and then hit check mark, it cuts out the circle for you. So that's how you do it. Very, very simple. And then the same thing before for saving. You literally just save it as centering ring demo, you know, and of course, whatever you choose to name it. Save as DXF, check. See, that's the setting ring, and you save it. For altitude, I'm just going to really quickly go over for, not altitude, sorry, for landers. You're going to have a setting ring, but the thickness of the setting ring is going to be a lot smaller. So I'm really going to quickly show for landers how you're going to do that. It's going to be the same exact process for a setting ring here. Just going to make this here. And then the second circle, but instead of having it around here, you're going to have it much, much larger. And I mean, you're going to have it around 2.7 inches in diameter, or sorry, in radius. So let me just make sure I get my math correct. 2.7 times 2, how embarrassing. 5.4. Yeah, that makes sense. 5.4. Okay, so you can see now how we have this much thinner centering ring. And in essence, the idea is that your lander is going to just sit right on top of that. So we're going to exit smart dimension, extrude boss and base, 20th inch. Check mark. And the saving process is the same. I'm going to cut that out just for time. But honestly, guys, that's most of the real components that you need to worry about for SolidWorks. Nose cones are provided. So honestly, I'm not going to demonstrate that because I'd like to finish in half an hour and I want to go over building. But if you guys do have questions about nose cones and you have, say, access to a 3D printer, then I can help you out. But otherwise, that's really it for what you need to do in SolidWorks. You know, that's the nice thing about the project. The SolidWorks is really not the most complicated. There's definitely a lot harder to do. So I'm sure that you guys will be able to figure it out with the tutorial that I just gave. But anyways, let's move on to the slides. Because now that we're done with SolidWorks, I can move on to building. So the way that building works is we're just going to talk about, just from the slides, components. You guys should be plenty familiar with it. I've been babbling on about components for so long. You have the nose cone, which sits on top, fins on the bottom, you know, you guys know that, and the body tubes, you know, the body. I can sort of just skip over couplers. That's what they look like, by the way. They kind of slide inside the rocket, just so it can kind of stay together. Motor tube and centering ring looks like this on the bottom. I'll talk about fin tabs later. But you can kind of see how the centering rings keep the motor tube in the middle of the rocket so that you don't have your thrust lopsided and then your rocket goes sideways. And then the payload bay, the way that it's going to look for you guys, it's going to be a coupler. And you can put bulkheads on the top and bottom. And these little hooks can help you take them out from the rocket and all. Motor retainer, that's what they look like. They keep the motor inside of your motor tube after it burns out. These are really important and provided. Shock cord, you can see that we use two parts. It's the elastic cord here, and then the little yellow Kevlar down there. And you'll basically get both ends. And it doesn't show here, but we'll have like a metal link that will be put together. If you don't mind, so that I can, yeah, sorry, Tyre, but I gotta leave you. Alrighty. So that's a shock cord, and then the parachute. I trust that you guys know what parachutes do. It makes that rocket does not crash into ground and get obliterated. Rail buttons, that is not how they look like. They're circular for us, but they can be glued and screwed onto your rocket. And that's what, you know, it goes on the guide rail so that your rocket flies up straight. The altimeter here, it gives you the altitude. And then the chute release, I was talking about this last week with the dual deployment. That's what it looks like. It's this little electronic device. There's a rubber band, and then on the other side is like a little pin that like clips into the other side. And so you wrap up the parachute all nice. You clip it around so that at apogee, the chute release holds onto the parachute, and then at a specified altitude for like 400 feet or something, the clip undoes itself and then opens up, and then the parachute can just have fun flying open. Fin slots. Okay, so we have these fin tabs, and I've been talking about them for 2 weeks now. But the way they actually implement that in the rocket is you're going to have your body tube, and you're going to cut these slots here, and that's going to be basically the size of the fin tabs. So, you know, the thickness is going to be 1/8 inch because that's how thick your wood is. And then you can get the length based off of the fin tab length in Open Rocket that we were talking about earlier. And then as it shows here, use an X-Acto knife and cut real carefully. The way that you can do it is like the cardboard can be cut in layers. So you don't have to like jab the thing in all the way and then all the way through. You can just slowly but surely cut layer by layer until you eventually get through. And that can get a very clean cut. It's better to do it slowly and carefully and correctly than to completely mess it up. And, you know, once it's cut, you cannot put it back on. So be careful with how you do it. So you wonder how you get straight lines on a circular tube. And there's actually a very handy strategy, and it's using a door frame. So the way that it works that the image shows here, you're going to have your body tube, and you're literally going to put it against the edge of the door frame so that your body tube is like kind of secure to the corner. You can take a pencil and run it down the body tube to draw out straight lines. Yeah, and use a pencil. do not estimate your straight lines. Your door frame method will get you pretty straight lines. And you can basically draw one, tilt it to an 1/8 inch, draw again, and you can basically get your lines that way. And I've done it before. It can be a little weird at the start, but once you get used to the door frame method, it is really the best method to get it right. And it's also free. As long as you're in a place that has doors with proper frames, then you can use the method to draw straight lines. So that's how you'll measure out your where you're going to put your own fin tabs, the slots there. Fin jigs. I am a huge advocate for fin jigs. So the way that it works is you have this wooden component here, and the way that I should have shown you, I'll go back to SolidWorks later to show you how you model it, but basically you're going to have a circle in the middle, and that's going to be where your body tube goes. You're going to have small rectangular pieces that your fins go on. And the idea is that as you're gluing on your fins on your rocket, you're going to basically put like all 4 fins in, and then slide the fin jig onto the fins. And it has to be snug. And the idea is that the fin jig is like perfectly measured with the laser cutter, so that your fins are perfectly straight. Because it is pretty difficult to properly align fins by hand. And if your fins are not completely straight, they have cants. And as I guys told you during the open rocket tutorial, you can't cant your fins. So using fin jigs is good. And I hope that you guys will have enough wood in the materials that we give you to actually make your own fin jigs if necessary. Or you can use extra material to cut one and share it with you guys. But yeah, no, that's a good idea. I'm going to show that to you guys afterwards. If I forget, please remind me. Shock cord mounting. Okay, here's how it's going to work. You're going to have your motor tube, and you're going to put your centering rings on it. So you can see here how this is actually external from the rocket right now. Basically, when you get all this stuff, take your motor mount, yeah, glue your centering rings on where they're supposed to be before you put anything in the rocket. Don't put your centering rings in the rocket and then try to put the motor tube inside, because that is extremely awkward. You basically get this like motor mount assembly and just shove the whole thing in the rocket. But before you do that, make your assembly and then tie the bottom end of your shock cord to your centering ring. And so the way that's going to look, you can see that there's 2 little holes here. The way that you get that, there's 2 ways, the hard way and the easy way. The hard way is you make your centering ring, and then you take the top one and you just drill 2 holes, like the TI Lab has drills. The easy way, I'll actually demonstrate to you guys really quickly. Let me go back to SolidWorks just super duper quick. SolidWorks, there it is. I did not need to do that. Let me go ahead and keep sharing my screen. That's my bad. Just so I can make sure that you guys see what's up. Here, take the centering ring, and what you can do is you can go ahead and hit sketch onto there. If you take little circles here and just like that, kind of, you can smart dimension it. And then you can actually drag it around. You can actually measure it if you want. Like if you were to smart dimension from the center of each circle, you can have it say 2 inches. So that it's like dead in the center of the centering ring. And then what you can do is take this, you should be able to copy paste. Yep, there you go. Drag it, say, over, I don't know, here, or closer. Smart dimension that to 2 inches. So you see that we have these 2 holes, and the idea is that you're gonna loop the Kevlar through and tie it there. So what you can do is if you go to features, because I didn't do this before, you can see that there's actually an extruded cut feature. So if we select this shape here, whoopsie, so smart dimension on. If you hit escape, you'll eventually turn things off. But basically, if you select the circle and go extruded cut, you can see that we can actually cut that little hole out. Hit check. And then there, you see this centering ring has a hole. And now if we select this shape, oopsie. Oh my, that was not good. Oh man, gotta go back to the sketch. That's my bad, guys. Let me just draw a new circle real quick. Make sure that's the same size. I'm just gonna sort of do this quicker. But You can have two little holes here. Let's go back to this. Sure to cut. Isn't that? Check. There. Okay. So I know these are lopsided, but you guys will be able to do it straight when you have time. So now you have these two little holes, and you can make a separate file, which is like centering ring with holes or something. Make that DXF file, and the laser cutter will cut these holes for you, and they're going to look really pretty. So the idea is that you're going to loop your Kevlar through that and tie it, kind of like what the image here shows. And the very important part is you do that before you install the motor mount. Because imagine this, the motor is going to be on the bottom of your rocket. You know, you're going to have this long body tube. If you don't tie the Kevlar before mounting the motor mount, you're going to have this motor mount on the bottom with some holes, but no Kevlar. So you're going to have to somehow reach all the way down the body tube, loop the Kevlar through the two holes and tie it down there. I don't know about you, but I can't do that. So be super careful to do the tying first, before you glue. The other thing, do not tie the elastic cord to this part. The elastic will burn from the ejection charge, and it will be bad. So tie the Kevlar to the bottom and tie it before you glue the motor mount onto the bottom. Super important. Okay, next slide, motor mount assembly. Oh, wow, this is a detailed little method. Oh, okay, this shows how you can pretty much put it together. So you can actually get a better image of what the motor mount assembly looks like. You have the motor mount, or the motor tube, sorry. And then the centering rings glued around it first, then you shove everything in. But there's two ways to kind of secure the fins around that. First method, which is what I used for my level 1, you make this, put it in there, cut out the slots here, then insert the fins into each hole, okay? That's what I like to do. The other way is you glue everything on first, then you could basically have the slots go all the way down, so you can basically slide the fins in. So if we see in this image, you see how the holes don't reach the bottom? You can make it so that these holes do reach the bottom, and you just like slide the fins in all in one. It doesn't really matter which way you do it, whichever way you feel is easier is the best part. And then when it comes to this, aligning, super important. Like the most important thing is to align your fins correctly. Glue joints. So when you're gluing your fins, one way that you can set up your motor mount is instead of putting the bottom centering ring in, you can kind of leave it out as shown here, so you can get the glue like kind of inside. But basically, let's say you built your motor mount like this, okay? Which I did, nothing wrong with it. The way that you're gonna drop my mouse, my bad, guys. The way that it's gonna look is you're gonna have your fin, and let's say you're using method 1, where you cut the slots and then stick the fins inside. Before you put the fins in, you're gonna put glue all on the bottom of the fin tab, and then you're gonna shove it in, okay, into the rocket, and make sure that it makes contact with the motor tube. So you can see how that's where the glue on the bottom here is. Then you're gonna put glue on like the sides, on like the top part that you can see that hits the body tube. Then if you don't put the bottom centering on, you can put glue up here, kind of like on this inside part of the body tube. Not necessary. I didn't do it, and I got my certification, but it's pretty good. It's really nice. And you definitely want a lot of glue. So you can see how this little image here shows there's a lot of glue. You want to kind of see that, just so you know that there's a lot of, glue holding it down. And by the way, when I say glue, it's wood glue, like Gorilla Glue is what I used, and it's really nice. So definitely, it's cheap, small bottles are cheap. So that's definitely, what you want to use for your rockets. Next up, glue joints continued. Yeah, you can see that they put a lot of glue. And then once you're done gluing all your fins in, if you didn't install the bottom already, you can just go ahead, put some glue on and put it right on top, and then just secure it as you wish. Nose cone attachment. For lander, you will need to remove your nose cone. So don't glue it. Same thing for payload. Don't glue it, because if you If you do glue it, if your lander's not going anywhere, and also your parachute's not deploying, so that's not good. And if your payload, yeah, your parachute's gonna go off, but you're not gonna see your payload, nor will you put it in. So really only altitude can, but there's no reason to. Man, I wish I had my rocket, but the way that you can basically fit your nose cone is if it's a little loose, what you can do is you can take tape, and you can basically put the tape on the shoulder of the nose cone. So let's go back to an open rocket here. So you see the nose cone with the shoulder. Sometimes the shoulder is a little too small. So what you can do is you can take tape and kind of wrap it around, and that can basically like increase the radius of the nose cone using the tape. And you just literally just friction. You put it in, and if it's kind of snug, but still easy enough to take out, especially for landers, it has to be a little bit easier to take out so that it can pop out during apogee. That way it can stay in during flight, but still be taken out later. Does that make sense, guys? I know it's kind of like a weird analogy to not an analogy, but a weird process to just kind of wave my hands around like this. But yeah, no, just use tape, wrap it around the nose cone if you feel that it's too loose, and then that can help fit it tighter. And of course, if you need a second opinion, like, hey guys, is the nose cone's like snug enough, or is it too snug? You can always ask us, send us a video, or even meet up on campus, and we'll go from there. Rail buttons. So the way that rail buttons are attached, you can see that they're kind of put on like this. This is actually what the guide rail looks like. And this is a better representation of what our rail buttons look like. It's the circular part, and the hole here kind of sits in the guide rail chat. And it makes sense around the nose cone or coupler connecting. Basically the coupler connecting the nose cone. Not the nose cone part that you see, but the part that goes inside the rocket to hold it down. You know what I mean? So like an open rocket. It's this part here, inside the body tube. Because that's what holds the nose cone down. So you want to increase that radius to keep it snug. Yeah. Rail buttons. So for for altitude and payload, because your rocket is split in half, the alignment isn't that big of a deal. Because in essence, the two halves can rotate. So if they're misaligned a little bit, we'll literally just like rotate the body tube and oh look, it fits now. If you are lander, you really need to make sure that they are perfectly aligned, because if they are not, you are not going to fit on the rail properly. My suggestion for alignment, you can use the door frame method, put it against the door frame and draw a big line right down your rocket, and then just make sure that they're centered on that line. And the way that you would attach it, I would both use wood glue or some like epoxy or something, whatever attachment method you desire on the bottom, and then you can see that there's a little screw. We have the screws on launch day, but I would like to give you guys the rail buttons so that you can secure them outside of launch day. So that's what rail buttons look like, and how you attach them to your rocket. Do's and don'ts for split rockets. So very important for your altitude and payloads. And then also for L1, I guess. So you're gonna have your coupler, and you're gonna see how it's gonna be glued like this. Glue the top half of your coupler to your rocket, not the bottom half as well. If you do that, you will basically have taken your split rocket and made it one piece again. So do not, under any circumstances, glue the bottom half. Just glue the top half and call it a day. The way that I glue it, the way that I did it, I literally had my coupler, just sprayed glue all over the sides, and then just shoved it as far as I could into my rocket until I just wasn't powerful enough to put it in. And then you can see that the bulkhead goes on the bottom half of the coupler, so you literally just glue the bulkhead there. Also on the bulkhead here, you should have a couple holes so that you can actually attach the top half of the elastic cord. So if you remember what I showed you from the centering ring earlier, do that to the bulkhead down here. I forgot to mention that earlier in the SolidWorks thing. That way you can take your elastic cord and tie it around, that bulkhead. And of course, tie the cord before you glue the bulkhead. Otherwise, it's going to be very annoying for you to loop the elastic cord around. Yeah, we still got time. Yeah, ensure that the glue joint is very strong, because if this bulkhead were to pop off for whatever reason, your rocket goes from one part to two, and that is not fun. So for the nose, don't worry about that. You don't need to worry about nose cone, egg protection, all that. So for this won't apply for landers, because landers will use the nose cone. Basically, for lander, you'll attach the top of your shock cord to your nose cone, and on the nose cones, there's like a little thing that you can attach shock cord to. It's designed that way, so it's very simple for you guys. Okay, this is just little tips for egg protection. You're just gonna glue stuff on the inside of the coupler to protect your egg. That applies for lander too. Basically, just you know, make sure that there's stuff glued inside of the coupler that makes up your payload bay / lander, so that your egg does not just smash into the side immediately. And then for egg protection system, you can glue your payload bay or attach in some way inside of your body tube, because if your payload bay moves, your rocket will not be stable. Yeah. Single tube rockets, lander. So you need the thin ring, you need this lander ring. I showed you guys how to do it. Basically the way that ring will look is it's going to be kind of way down on your rocket so that your lander sits on top. And I've seen instances where the lander ring is like in the middle of the lander. That's not good. Don't do that. You know, basically, if we go back to open rocket, I can just very quickly imagine if like we had a lander here. The way that would look is if we centering, and then inner diameter is going to be really small or whatever. Actually, it's going to be like that. It's going to be kind of like down here. Imagine if the coupler weren't there. It's going to be kind of like down here or something, so that, you know, your payload or your lander can sit on top of that. If you don't have that, you will not fly. And yeah, so make sure that you have that little centering ring in there. Yeah, make sure they have feet on the lander's legs, just so it can like kind of sit on top of the lander ring. Yeah, another thing to mention, guys, one mistake that my team made: make sure that your lander will fit in the rocket. We did not do that. It did not go well. We had to like basically cut the legs off because it did not fit. So make sure they have a lot of clearance for that. Don't glue your nose cone. That is so bad. If you glue the nose cone on top, you will have a bad time. And then the friction fitting thing, absolutely amazing. Alrighty, I think that sums up that slide. Exploded diagram. This just kind of, you know, it's really cool looking, and it just basically is an overview of what we've talked about before. And it gives you an idea of what the split body tube looks like with the tube coupler. You're going to glue it to the top half, and the bottom half will just be not glued so that it slides right on and off. This coupler is your payload bay, basically, with the bulkhead on the bottom to secure it. And then you have your motor mount and fins. Kevlar on the bottom, elastic cord on the top. Super important. Make sure that you guys remember that before, you know, gluing anything. Yeah, that's it. Actually, yeah, that's it for building. And we have time to spare. Yeah, I think that basically covers everything that we need to know. So do you guys have any questions at all about today? I know that there's a lot to cover these past 2 weeks, but this is basically what the project looks like. The basic process is, first you do open rocket, get your basic design out, then you're going to go onto SolidWorks, model up all the parts. Actually, hold on. Let me make fin jigs for you guys. I totally forgot. Let me just show you that really quick. Yeah, that's a little messy on me. So here's how a fin jig will look like. If you guys have the spare wood, you're going to sketch. First, make a little rectangle, okay? It's going to be like a square. I don't remember how big this needs to be, but it needs to be pretty big. Yeah. Then let me make this 6 inches. Make this a 6x6 piece for now, but it might need to be expanded on later. Center it. If you hit this line and then hit the center, you can just make this 3 inches and then it's defined. That will not be big enough, but we'll worry about that later. I'm just going to really quickly sketch this up. The dimensions will not be very good, but you get the basic gist. So here's how it's going to look like. So the way that a fin jig is going to look, you're basically going to need a hole in the middle where your body tube is going to go, and then you're going to have little rectangles that go out where your fins go. So what that's going to look like, you're going to put your hole. I'm going to need to make this a lot bigger, but you're going to make this. Now let me real quickly. Let's make this. Let's make it 24 inches, just so we can make this overly large thing, and then we'll fix this later. So this needs to be 12. This needs to be 12. Okay. So now we have a much bigger square. Make this 6 inches in diameter. And now you might be asking, wait, sorry, the outer diameter. It's like 3.1 inches actually. So it'll be 6.2 out here. So if you guys remember, that's like the outer diameter, but it's like, wait a minute, don't we need a little bit more? And the answer is no. When I was making my own fin jig, I realized that if I made the SolidWorks file the exact same dimensions as the thicknesses and outer diameter of the body tube, it fit super snug. I've tried so many fin jigs trying to make it just a little bit bigger, and it never works in my favor. But when I did this, fits perfectly. I'm serious. So that's going to be where the body tube goes, and make sure that this is the outer diameter, otherwise it will not fit. And then what you're going to do is, it's going to be a little bit weird, but we're going to make lines. And so the way that I did it is I have like a center line here, and it's going to go out to your basically how long your fin is going to be. So it's going to be like this, and it's going to be a little weird, but you're basically going to, oh, what happened there? Okay, you're going to make these lines here, so you can kind of catch this idea that I'm kind of making this nice straight rectangle on the side. And so I'm going to have a 1/2 of an inch, 0.125 divided by 2. I don't feel like doing math right now. 0.125 divided by 2 is 0.0625. So I'm going to make this here. Come on, load. Oh, 0. It's gonna look real small, but that's how it is. Fine. And then this length here is going to be how far out your fin goes. So that's actually going to end up being the fin height. So if we go back to my fins, fin height for me would be 2.7 inches. You can make this slightly smaller, actually. No, make it slightly smaller. Because of this angle here, it's just going to like kind of fit right in. So you can make it like 2 inches out, I would say. Smart dimension. Yeah, no, this is way too big. 2 inches out. That's good. So what we're gonna do now is we're gonna take this line in the middle and Control X. Oops, cannot be cut. Ah, man, I forgot how to do this. Yeah, sorry guys. Trim entities I think would work. Yeah, no, I always forget how to cut that little piece out. I think, I definitely did this wrong. I think what I'll do is I'll make you guys fin jigs just so you guys don't have to worry about this process. But basically the idea is that if you can make this rectangle nice and straight, you'll be able to cut this out, and then you just repeat it on these sides here. And then of course make this big wood piece smaller. And the idea is that it would fit right into the rocket. It's been a long time since I've made fin jigs, so I definitely have to refresh myself on the process. So my apologies on forgetting that little bit. Okay, back to the slides. Basically I've gone over everything that's necessary. I need to go over fin jigs again. I'll just help you guys out if you want to make your own fin jigs. But I've seen teams eyeball fin alignment before. If you guys have any questions, I know that I'm a little messy when it comes to teaching. There's a lot of my brain and it's hard for me to get it out. But I hope that I've delivered it well enough for you guys to understand. And if you guys have questions, of course, message me or any of the other leads for help. Just like kind of closing announcements before 7:30. If you guys have not filled out the team sign up forms, please fill it out. It's been up for a week. I'm going to close it during the weekend. So if you guys are not on the list, you will not get a team, in essence. You know, there's been enough time. Another thing is that if you have not paid your dues, you will not be put in the team because, you know, you need to be an AIAA member in order to participate. So if you guys have not paid your dues, please pay your dues. You know, once teams are formed, I'll send an announcement out in the Discord. Chat's going off. Anything we need to know when designing? Oh no, that's fine. I mean, it's fine that you came a little late. Just watch the video again. Yeah, I'm not sorry, I'm not gonna like go over the whole process of making pins again. It'll just be uploaded later on YouTube tomorrow or something. And you can just go over that again later. You know, I feel mean, but yeah, it's gonna take a bit. Yeah. Anyways, I was talking about announcements and fill out forms, pay your dues if you don't do either of those things, or if you don't do both. Okay, cool. Thank you. If you don't do both, you will not have a team. So please, guys, fill out forms, pay your dues. Oh yeah, and I was saying that I'll send an announcement. You'll have an Excel spreadsheet of what the teams look like. If you don't have a team, no worries. We'll put you in one and you'll see who you're working with and you can start DMing them and getting your team dynamics going. Once teams are formed, I'm going to give you guys a couple weeks to go ahead and do Open Rocket. And then once you're done with your Open Rocket files, you'll be able to receive your parts and start building your rockets. And definitely, you know, the sooner you get things done, like let's say you don't have to wait until the due date to turn things in, like any good assignment. If you turn it in early and we approve your design, you will get your parts earlier so you can just start building. Assuming that we have the parts, we've been ordering them. But yeah. Oh, you'll also be assigned a lead that will help you primarily. You know what I mean? So you'll have your team and then who's helping you. And not that you can only talk to them, but that's like sort of your primary contact, if that makes sense. Just so that we don't have the team just like reaching out to random officers and asking a bunch of questions. It's nice to have that order. But yeah, no, basically all details are to come in the Discord. Please look at the Discord a lot, as I always tell you guys to do, because that's where I talk to you guys. But yeah, I think that really does sum up the tutorial. If you guys have questions, you know, and you're watching this later, or you're, you know, one of the other four, and you don't have your questions now, always ask in the Discord or DM me or any other leads. But yeah, I think that'll wrap it up. I'll see you guys later.